Hello, good evening, everyone. I'm Kamna Mishra from IIT Mandi, School of Mathematical and Statistical Sciences, and I am here as a TA for this course, Essential of Data Science with R Software, Sampling Theory, and Linear Regression Analysis. And the course instructor is Professor Salab, who is from Department of Mathematics and Statistics, IIT Kanpur. As usual, these are the class timings for the class I will be taking in this course. These are the links for uh, needed, which are needed. Uh, okay, regarding today's class, the main points are basically we will see that what is random sampling firstly. Okay, so the random sampling, if we will say that uh, whenever uh, we want to understand a population, so if the size is like uh, is something which we can consider to study, then we consider the whole population, otherwise we take a sample of it. Uh, so, which that sample needs to be the representative one, and then because we do not want uh, like that chances of selecting one unit is other than chances of selecting other unit, then the sample is not random. So if it is not random, then it is not necessary that it will just show up what is happening in the population. That is why the simple random sampling happens. So simple random sampling is basically that we have a population and we want a sample. So that sample to be random, each and every unit, let's say there are 100 members uh, in some society, let's say, or anything like in academics or in public or in any society, in a college, etc. So if we have 100 members and we want to choose 20 members out of it, and there is no criteria like that we want to choose men or women, or according to the age, like there is any minimum age or something. If we do not have any kind of criteria like this, then what we do is that we do the random sampling. Now there are two types of it. So uh, first is basically SRSWOR and SR. Next is SRSWR. So SRS, basically this, just change this. SRS is basically simple random sampling. Now the SRS is SRS, sorry, SRSWOR is without replacement. So SRSWOR means simple random sampling without replacement. So without replacement is basically meaning that we have a sample. Once we have chosen one uh, unit out of it, then we cannot choose this unit again. And the next one is that simple random sampling with replacement. That means once we have chosen one sample, then again we can choose this sample. Again, we can choose this particular sampling unit. So now there, if you will take just a mathematical example, then there is like 10 balls, and then you can choose ball and you have given the numbers to it. Then if you will choose one ball, then you can choose it again if it is with replacement, and you cannot choose it again if it is without replacement. But the real life example can also be there, like we are using, because there are real life examples. So one of the example we can take is, uh, let's say there are let's say 100 student, or let's say the number is small right now. So let's say there are 10 students. Okay, so let's say there are 10 students: A, B, C, D, E, and then F, G, H, I, J. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say these are some names of, let's say, some labels I have given, or you can give 1 to 10 numbers. And let's say these people wants to join a college, or these people wants to uh, join PhD, let's say. So I'm a PhD student, I'm giving the example similar to it. So let's say they wants to join the PhD. Now to join the PhD, what they need to do is that they need to go to some college for the interview, or for the written, whatever is required in that. So let's say there are five colleges, or let's say there are three colleges just. So C1, C2, C3. Let's say these three colleges are there. So now these are the students. So based on some criteria, uh, they will be selected here. Okay, so now in one college, if they have asked for the interview to A, B, G, H, and I. Let's say they have asked for them. Now they, since they have taken them already, there is no chance that they can take their interview again. So if I'm going to C1 college and I have given my interview, so they will not take my interview again. Okay, because doesn't matter if it is good, doesn't matter if it is bad, best like bad, until and unless there is no other round. So if it is just, we are assuming here there is one round, so they can take these student for interview, or they can select student. So that can happen only one time. So if they have asked for A, there is no meaning of asking for A again. But there are three colleges, so is this can take also, let's say this has taken this, and let's say this has taken B, C, and G, and J. Now, here you can see there is a repetition, there is a repetition, there is a repetition, there is a repetition here, right? So, right now they are different, so they can select A more than one times, because they are selecting two other at two other colleges. So it is making sense that A, B, C, D, E, let's say. So for one student, let's say I'm talking about A. So let's say there is a student A, so who has selected to get to give an interview in C1 college. So he cannot be selected in C1 college again, but then if there is C2, then he can be selected in two colleges. So C1 and C2, in both they can be selected. So there is a repetition of A in both the college, in the colleges. So A has the chance to give in C1 or C2 both. So there is a repetition. So if colleges are different, there is a repetition. So this is one of the thing where you can see that repetition is happening not inside one college, but for A. So for A, there is nothing like that. If A is selected in C1, then A can be selected in C2 or C3 or both. Okay, so this can be selected in other colleges also. So for A, this can be a replacement. Okay. So this is one of the example of SRSWOR and SRSWR. Now the next thing is that the probability of choosing a unit at any step is same for SRSWR and SRSWOR. Now this is uh, where some confusion lies. So we will see its proof later on. Uh, the next thing is that the procedure of selection of a random sample. So selection of a random sample, how it will be done? As I have told, just give them a number or label and then choose any number randomly. Now, uh, here comes the problem when we say that choose a number randomly. So now this is somewhere where we have not chosen it randomly, where we have chosen it with some sense that okay, there is some criteria. Now, if I will say that we want to choose a number randomly, uh, okay, so now if you will see in anything, like if we want to go like any sports, then we try to select our best, uh, right? So there is very less in if it is very much mattered to that, uh, but let's say there is a program. So what I'm doing is that uh, I am saying that in academics, let's say uh, there are 20, or let's say a big number, there are, let's say, 50 people. Let's say there are 50 students in a class. There are 50 students in a class. Okay. So we will firstly assign them the number 1, 2, 3 up to 50. Now, what I want to do is that I am saying that so that a person can be a student, like I am teaching a student, and I want them to be a bit representative, so that they can stand in the social events. They can uh, like in the time of presentation, they will not have any kind of hesitation or something like that. So I'm saying that I am introducing a new program, and in that like at every day there is one person who need to give speech, or let's say in every week. Okay. So uh, what I'm doing is that, and once the person is selected, they do not need to give the speech again. Okay. So let's say uh, there are week, so 1 2, so up to W50, right? Or there can be holidays, or then can be, let's say, a problem in the program or whatever. Or let's say I'm saying that we will see for 15 weeks, and after 15 weeks we will see if there are any changes in the students way of presentation or not. So if it is good for them, then we will continue it, or otherwise we will not continue it, we will stop it, and we will try to find some other way. Because it may happen that the teacher is not present, it may happen that the students are not serious about it, so they just do, like they just made because they are forced to do that, and that is why they are not interested in it. So there can be other reasons. Or it may happen is that student took it as an opportunity, said, so they are like trying to do their best in that, so we can continue. So right now what we are doing is that we are saying that for 15 weeks we are doing this program, and after 15 weeks we will see what is the result, and based on that we will continue this program or discontinue it. Okay. So now in the week 1, I want to choose out of random, so 1 to 50. Now, uh firstly is that if I know each and every student, so it may happen is that I will do some kind of biasness towards, let's say if I think that this student is very bright, so in 15 weeks he should have this kind of opportunity, so I want that person to give the presentation. Or let's say in the opposite, if I'm thinking that this person really needs improvement in their skills, so I want this person, I do not, the bright one can take care of himself or herself on its own, so there can be some biasness. So firstly is that we are not giving the names to the of the student, so names are not given, so that there will be less biasness. So names are not given to have less biasness. Name are not given so that there will be less biasness. Now what we are doing is that we have assigned 1 to 50 numbers. Now in numbers also there can be biasness. How? That if somebody will say me 1 to 50, there is high chance that like there's not high chance, but there are chance that I will not select a simple number like just 10. Or there may be some person who just select 10, or who just select like, okay, this is one lucky number, then I'm gonna select this number. Or let's say somebody is like, this is my birth date, so I'm gonna select this number. Or this is like this can be anything that maybe I'm thinking that maybe the numbers is assigned in that kind of form, so I will select in that way. So even if we will take just numbers, uh, then there is a also some biasness. Some biasness is there, because there can be a lot of thought process in that. So we are also, rather than choosing just number like 1 to 50, what we can do is that we can do some cheats. So if we will do chits and then we have folded in a equal way, not that the color chits we have taken, let's say blue color or white color or pink color or any color, and then we have folded a chits in a similar way. So there is the chances of biasness are very less, right? So biasness chances are very less. So there can be a lot of method in random sampling which may seem to you random, but it is not random. So now we can do cheats and then we can select some numbers. So let's say for this we have selected 14. Now the program in our software or in any software, this is also not exactly zero biasness. There can also be some biasness, but the chances are really less. So this is one of the way. So let's say here it is 14, let's say here it is 37, or somehow here we have gone through this and we have used the cheat method for all the times. Now in SRS WR WOR. So in SRS WOR, if 14 is selected one time, then we are not gonna select this the student of this uh, again. So that chit will be removed, and the next one will be chosen from the remaining one. Okay. Now, so for the SRSWR, uh, if there are 1 to 50 students and I'm selecting uh, one number, so the chances is 1 by n. Now for the next one, because I have replaced that, the chances are again 1 by n. So it is 1 by n for all. Now in SRSWOR also the chances are 1 by n for getting selected each and every student. Now here is some uh, confusion, that why is that, because once I have selected uh, out of once I have selected one, then there should not be like it if it is 1 by n, 1 by n, 1 by n up to n. Why it is 1 by n? Because the chances should be less. So once it is 1 by n, there that should be 1 by n minus 1. So here is one of the proof sir has given in the slide. But to make it simple, like not just whole mathematical, what I want to say is that I have, let's say, one, 2, 3, 4, 5. Let's say I have 1, 2, 3, 4 up to 5. Now, in 1, 2, 3, 4 up to 5, I have, let's say, selected 3. Okay, so right now the chances of getting selected, so uh, getting selected. So let's say for chances of this getting selected is 1 by n. Now, if I am saying that now I have 1, 2, 4, 5, so chances should be of getting selected of 4 should be 1 by or let's say 2 should be 1 by 4, because 3 is not gonna select anymore. But there's a catch. So catch is that probability of getting selected 4 in second chance. So when would this can happen? So this probability, or let's say this event, okay, like selection of 4 in the second chance, this event can only happen when 4 is not selected in first chance. So if we are saying that we want the probability of getting selected of 4 in the second chance, the thing is that there, if it is selected in the second chance, that means it has not been selected in the first chance. If it has been selected in the first chance, it is not possible to select it again, because we are doing SRSWR, right? SRSWOR. So in this, probability of getting selected for in the second chance is it already means that event is only happening because 4 is not selected in the first chance. So that means this probability will be multiplied with this. So when can this happen? The probability that 4 is not selected in first chance. So that means out of 5, this fourth one is not selected, which means this probability is n minus 1 upon n. This means that uh, we have selected 1, 2, 3. We have like we can select 1, 2, 3, 5, but not 4. So this is not selecting 4. And then in the first chance, and then selecting 4 in the second chance. So in the second chance, now the number we have is that we have 1 by n minus 1, right? So this is the probability of getting selected in the second chance. Now if we will multiply both, this will be cancelled out, so it will be 1 by n. So here is like understanding of it. If we will go through the whole proof, then it says that we have taken an event AL, that event that particular jth unit is not selected at ith draw. So for that, the probability of selecting jth unit at kth draw, jth unit at kth draw The probability of selecting of it means if it is selected in the k row, that means it has not been selected in the a1 in the first row, in the second, or in the k minus 1 row. And in AK there is a bar, so that means it has been selected in the AK. Intersection means it is and, so it is not selected in first and not selected in the second. It's not that it is selected in first and then maybe selected in the second one. No, so it has not been selected in the first, not in the second, not in the k minus 1, and exactly at kth row. So for that, this will be, now this is the simple probability uh, uh, property. So we can say that it is PA1, PA2 given A1, A3 given A1, A2, and etc. So PA1, so not selected is 1 minus 1 upon n. Then A2 given A1. So A1 happened already. That means there are 1 minus, there are n minus 1 remaining. So 1 minus n minus 1. A3. So similarly, we will go up to n minus k plus 2, because here it is up to k minus 1. So when it is 1, it is n. When it is k minus 1, it is uh, n minus k plus 2. And at the end, we can see that it is getting selected is n minus k plus 1. Right? So it will be n minus 1 upon n minus 2. So if we will do this, these all will be cancelled out to the next one, and the remaining one will be 1 upon. So this is like, if you will see through the mathematical form, you can see, or if you want to see from the logical perspective, then you can see that in it can be selected in the second row only when it has not selected in the first row. Otherwise, there is no meaning of selecting in the next row. So this is one of the thing that why. So 1 upon n, it is because n is the size of population. Now, the next thing is that we have sampling unit and samples. So, sampling unit and sample, what is the difference between it? Sample is that we have, uh, let's say, uh, here if I have 50 student, and in each class, let's say I have increased the time, so rather than 10 minutes I have now 60 minutes. So I'm going to choose 6 student in one class. Okay, or let's say 5, so there will be some kind of switching time in between, like 2 minutes or some question answer type things. So we have selected, now we are selecting 5 out of 50. So 5 out of 50. Now this 5, this is a sample. Okay. And if I'm saying sampling unit, so unit is like 1. So unit, when we are saying unit, then it will be 1. If we are saying sample, then it will be 5. So we are selecting, uh in general we say n out of capital in that way. Okay. Uh, so now, if we will say that probability of selection of so sampling unit, so for SRSWOR, so now the probability of drawing a sample, the probability of drawing a sample is 1 upon NCN. So basically, out of 50, we are choosing 5. And in SRSWR, the probability of this will be 1 upon n to the power. Okay. Now, for SRSWR, it is quite just simple. Why? Because for let's say we have for the first one, uh, if I'm drawing a sample out of n, so if I want to choose n sampling units out of this, so n sampling units is basically we have the sample size of n. So if I have 1, 2 up to 10, uh, and I want to select the 3. So for the first, like I want to select a sample of 3. So to select a sample of 3 is that it can be uh, the simple way we write is 10C1. So out of 10 we have selected any, out of 10 again we have selected any, and then out of 10 we have selected, right? So this is in SRSWR. So with replacement we can in sample of 3. So the probability of drawing uh, the sample of size 3, let's say, it will be 10C1, 10C1 and 10C1. So it will 10C1 is basically 10, so it will be 10 to the power 3, right? So this is simple random sampling. Now uh, when we see this, now when we see SRSWO, so here we want to select n units of the are selected in a sample. So let's say we give them a name. Let's say A1, A2 up to AN. Right now, A1, A2 up to AN we have given the name. It is n units out of n. Right. So here for selecting this, let's say PA1 would be n upon n. Why it is n upon n? Because we have right now all the uh, here is the population and we have all the units, like all the places. So let's say you can see it as a box, right? So seeing it as a box helps actually. So here if you will see as a box in SRSWR, so we can see that out of 10 we can put any because it can come here uh, with replacement due to. Now in 10, it is SRSWR. So we have selected one unit out of the population. So this is let's say I have selected the first one, right? So for this it is n by n, right? The probability is n. Now one place is filled. Now one place is filled, so number of units we have remained is that we are remaining with there are n numbers, n minus 1 number of units we have remained, and the population out of n minus 1. So it will be n minus 1 upon n minus 1. This will be n minus 2 upon n minus 2, and up to that will be uh, 1 upon n minus n minus 1, right? So if we will multiply this, uh, the probability of uh, selecting n out of capital N, uh, then it will be n upon n multiplied by n minus 1 upon n minus 1 and up to 1 upon n minus 1. So this simply leads to 1 upon n, and you can write it like this, or 1 upon n c n, like this. So this is the way you can think. Now if we will go through one example, let's say uh, no, there is some issue. So let's say we have uh, one ball here, one, two, three. So selecting of a sample will be like 1, 2. If we will do SR as WOR and we want to select 2 out of 3. It can be 1, 2, it can be 2, 3, it can be 3, 1. Now, there is 2, 1, then 1, 2, then 2, 1 is same. Why exactly? Why exactly? Now, if we are selecting a unit, then it is not the case because it has selected in the first row or it is selected in the second row. These two are different thing. So if it is selected in the first row, that means let's say 2 is selected in the first row. That means 1 is not selected in the first row and selected in the second row. But in the time of sample, it is same. Why? Because exactly it is in one place. Okay. It is not that which is coming first. So if I'm saying that I'm selecting like here, when we are saying that I'm selecting for week 1, week 2 up to week 15, now there is a difference because the person who is getting first, let's say this the person with the roll number 14, so it is getting first. Now in the first, what is the problem? There may be like he doesn't have any format or a lot of things. The person getting on the second, now that person knows a lot about the presentation like he has seen. Now if I will say about week 15, now that student have learned a lot of things by like understanding others, right? So there is difference of getting selected where when you have selected at 1 or 2 or 3. But when I'm saying that for week 1 I have time and I am selecting 5 student, so uh, among 5 also, there can be like 1, 2, 3, 4, 5. But if I'm selecting as a member or something like that, let's say not for presentation, or I'm just selecting 5, I am saying that all 5 need to write something, or let's say all of 5 need to solve some question in a board. So and they are not allowed to see each other's work. So here the it will not matter that one comes first or second comes first. So this is the thing. Okay. Okay. So this is the difference between sampling unit and samples basically. Now if we change the color also, then also the probability will be same. Okay. The next thing is that we have done all of these things on uh, theory. So now we want to use this in our software. So how we can do it in our software? Now this matters that uh, why do we need to do it in our software? Okay, so in the real life, you may not have this data of just uh, 50. You may have some large data, let's say 500 or 1000. And in reality, actually, if we go through the population or if we want to draw, so basically, we say that the good sample is basically when you have the sample size greater than 30. So if sample size greater than 30, you can imagine that the population size needs to be a lot bigger. Also, if we want to we cannot just say based on one sample that the whole population is behaving like that. So most of the time we take a lot of samples. So let's say I'm taking, let's say, 20 samples or 30 samples. So if the population size needs to be large enough to take that much of sample and go to a conclusion. Because if, let's say, the population size is 20 or 30, here we are taking in the example in the theory part, but let's say in real life it is 20 or 30, then there is no need to take a sample out of it. It is already in a form of sample. Okay, so for that we need the softwares, right? So so we will use the R package for that. uh, Okay, so for that we will take the take help of our software, and then we will use this. There are two packages basically which will help us in this. So there is one package called sample. So we can do some search here. So there is sample, there is sample.int. So basically we are gonna use these two packages in our work. And for me, so these packages, you can see that this packages is coming in the base. Sorry, this function is basically in the incoming is coming in the base package. So base package is already installed as far as I know. So you do not need to install it or do the library thing, it is already there. Okay. So now here, so firstly we will understand what it is. So you can see that there are two already given. So first is sample x size replace equal to false and prob is equal to none. So we will see each and every word. So firstly I'm just making it a more clear. Okay, so x is either a vector of one or more elements from which to choose, or a positive integer. So x is basically what? X is our population. So in population, let's say it is 1 to 50, or it can be different. It can be like we can see that in later on that we can make use of characters also. And then the next is n, a positive number. So number of items we need to choose. So size we can give, like what is the size? So size is uh, right now here the sample.int is basically integer. So sample.int means if we will give n, so rather than giving x as 1 to 50 or 1 to 500, if we will put just 500, then it will understand on its own that okay, in between 1 to 500 I need to choose. Size equal to n. So size equal to n is basically, it is not just n all the time. It is not just like if we have for 500 we need to choose 500. We can choose this 10 or 20 or any we want. Okay, so this is let's say out of 500 I want to choose some sample size of 20. Now replace equal to false. So replace equal to false mean we do not want replacement. That means it is happening without replacement. So without replacement will come in this case. The next is prop is equal to null. Now what does that mean? Okay. Now here is a sample. uh, let's say out of 1 to 500 the size is equal to or let's say let me do it very small so that I can tell you what is the prop. 1 to 10 size is let's say 3. Okay, and replace is equal to false, and then prop is equal to null right now. Okay, prop is equal to null. Now, if we will change this prop, what will happen? If we will give, let's say, any number in place of this prop. So, let's say I'm doing sample 1 to 10, and okay, so sample 1 to 10, let me just remove all these things and then work it out. Okay, sample 1 to 10 size is 3. So in general replace is false. Let's say I'm doing replace is false. So which is anyways true. So if I will say replace true, then it will be 4 to 2. Okay. Now prop. Prop is basically I'm saying that it is point 0.1, point 0.1, point 2, point 0.05. Okay, so what it is saying that it is incorrect number of probabilities because we have not given for all. Now it is 1, 2, 3, 4, 5, and let me just copy all of it. Now here what you can see is that what you can see exactly in here. Okay, so let me just copy this here and let me say this. Okay, so what is happening in the first one when I have given replace is big when I have not given replace anything, so it is 10 to 8 because in general replace is false. When I have given replace true, so when replace true I have given it is 2 is repeated, right, because it is taken away. When I have given probability of length 5, there is an error. What is the error? Incorrect number of probabilities. Now the next thing what you can see in all three samples, number 3 is present. Why? Here I have given the probabilities point 0.1, point 0.1, point 0.2, point 0.2 and point 0.2, and here point 0.2, point 0.2, point 0.2. So I have given the probability point 0.2 for 3 and 7, right? So what is happening when it is taking the sample, firstly it is saying that the replacement is true. So it has repeated here 3, here 1. It has not repeated anything in here. But since the probability of this is zero point 0.2, then the number of getting selected of 3 is increased. Also, it is the same for 7. So if we will, let's say, run this program, sorry, 8. It is not 7, it is 8, 9, 10. So for 8 it is true. So in the next we can see that 8 is also selected again and again, but 3 is selected firstly. Maybe now here comes where we say that it is not all, obviously all random. So there is a chance that in starting it is taking more, so it is 3 3 3 came. But the probability of 8 also is the same, it is zero point 0.2 zero point 0.2 zero point 0.2, but it is not taking 8 in the starting, whereas it has taken later, like 833 and 686. But the 6 is also came, 3 also came, so 3 came more than 8. So this is where we say that even in the programming also it is not true always. Okay. But this is the role of giving the probability to some numbers. Okay. So it just increase the chance of it getting selected. So it will come more often. In general, probability is null. That means getting selected is have the same chance. Okay. The next thing is that sample dot int. So rather than giving x, we can take sample dot int. I'm, let's say, saying 500 and size equal to 12. So it has given me just any 20 out of this 500. Okay. Uh, Now in this we can do some like we can play with it, that we can change that in between x you choose when x is this, when x is greater than this, or let's say uh, here is 500, or let's say if I want to see that uh, x is, let's say, to 500. Now x such that x when it is equal to 0, right? So now if I will say why I want to take sample when in size equal to 60. So now what I have done is that I am only taking the samples, I'm only taking the samples which are divisible by 15. So it has some rules now. It is not random exactly, but it has some rules now. So if I'm selecting so this criteria, this is the criteria which I have created numerically. Now this area can be created categorically also. How this works exactly? So let's say you have uh, let's say you have of amazon a amazon sale. Okay, so you have an amazon sale. Then what will you do is that uh, okay, now if you will see the items, so items is basically, you see here 1 2 up to, let's say, 100. Okay, The item you are saying is that, let's say you have one, two, you are seeing some items here, and then you go to next page. If you will not like the items, you have some items here up to 100. So there are very few people, like there are almost no one who will go up to 100. So what we do is that we use some kind of filters. So in that, like here, when I'm using the filter like x is divisible by 15, what we can do is that we take the filter like uh, on the review. So it the whatever the product, it can have the review 1, 2, 3, 4, 5. So what we do is that we take which is greater than 4. The rating is, sorry, the rating is greater than 4. So we select when, sometimes when the rating is greater than 4 or greater than 3.5 or something like that. So out of, let's say, 5,000, so the population, when we have the 5,000 population of Amazon, of let's say a product, let's say a shoes or a shoe or a watch or anything, then out of 5,000, and I'm saying that rating needs to be greater than 4, then I have already reduced it. So now there will be, let's say, some 600 items remain. So out of 600, I can again do that. So then we can create this, whatever I have done this here. This is like one of the conditions. So this condition is saying here numerically, we can use this. We often use this in real life to get this sample. Now from that sample, we will select the better one. Okay, so this is sample. So sample.in can be used by this, sample can be used by this. Uh, Now the replacement can be true or can be false. So we can see that here the replacement is true or false, how it works, and the probability also. Okay, so now in place of this condition, like x is divisible by 15, we can take the other condition also, and then we can work on that accordingly. Now, the next thing is that we can take right now we are taking just from a data vector. What we can do is that we can create a data frame also. So for the data frame also, for the data frame, what we need is that, let's say there are two, so let's say I'm saying this Z1, uh, say letters and capital. So, letters. Okay. 1 to 8. Oh, oh. Letters to, why it is not working? Does it work with, okay, sorry, so I need to give it like in this form rather than in this. So it is 1 to 8. So I have taken letters 1 to 8. We can take like C and then 1 2 or whatever is needed. So Z1 can be this, and Z2 is, let's say I'm doing some random numbers, or let's say I'm doing it, I'm creating a sample, or let's say we will take that later. So if we will take place by 10, let's say I'm taking 54, 17, 19, 24, 78, 6, 7, Okay. So Z2 and Z1 is uh, of the same. Now, what we can do is that we can create a data frame. So data dot frame Z1 comma Z2. So here is the data frame, and let's say I'm giving it as name Z. So now what we can do is that we can select with the letters also. So let's say I want to select the sample, and then uh, from Z1, if I will now say just data frame and size 3. So you can see here that it is not important that Z1 needs to be a numeric string. We can take Z1 also as a characteristic. So it is EGI. So it can be anything. It is not important that it needs to be a numeric one. It can be this. Uh, or let's, if I will do Z, then it has saying that it cannot take samples uh, larger than the population when replace equal to false. If I will say, let's say replace equal to true, what it is doing, it is taking z2.1, so it is just doing the similar one and it is not creating. So we need to give the data vector in place of data frame, so it needs to be z1. If I will say with replacement, it will be this. If I will say, so here I am taking the z2 is vector of numerics and this one is vector of characteristics. You can say this is character as this. So here it is replacement is true, so it is 12 34 34. So this is true, is that means with replacement, and if it is false, that means it is without replacement. So these were regarding the today's class, like how do we use the packages and how do we use uh, with replacement, without replacement, and how we can give the probability to one, as so that means one is more important than other. Okay. So now we will go through some questions, and we will solve it one by one. Okay, so the first question is that a simple random sampling SRS without replacement of 7 items is drawn. Just a minute. Is drawn from a lot of 70 items. So basically, we have 70 items, 1 to up to 70. I want to choose 7 items. So let's say it is A1, A2 up to A7. Now it is saying SRS WOR without replacement. What is the probability that any specific item is included in the sample? So any specific item is included in the sample. It is not saying that uh, uh, it is in the first time or second time and anything. So at each and every stage, what we have seen is that in the first point, that the probability of choosing a unit at any step is same for SRSWR, SRSWOR, which is 1 by n. So here it will be 7 out of 70, right? So it is n by n basically, because it is uh, the sample size is n, and this is uh, the population size is 70, so it will be n by n. So this one is basically 7 by 70, so we can say it is like point 0.1. So point 0.1 will be the correct answer. Okay. The next is that a librarian draws four book from a shelf of 20 books using the sampling with replacement. So with replacement. So SRS W R. Okay. Now, what is the probability that particular book is selected at least once? So that means if I have 1, 2, up to 20 and I want to select A1, A2, A3, A4, then a particular book, let's say that particular book is named as uh, P, let's say, then P is needs to be selected in either A1 or A2 or A3 or A4 or in A1, A2, A1, A3 or like a lot, because it is like with replacement. So it can happen that it can be selected in all it, but the thing is that we want to find the probability that it is selected at least once. So, what will be the probability? So, in that case, when it is at least once. So, uh, let me have some space for that. Okay, I need to adjust that. Okay, so probability of getting selected at least once is basically that 1 minus probability of not selected in a in all four, right? So if it is 1 minus not selected in all four, so if it is not selected uh in all four, so this is now this not selected in all four means probability of uh not selected in first one, right, into not selected in the second one, right, into not selected in the third one, into not selected in the fourth one. So if it is not selected in the first one, okay, let me just remove this. Okay, so it is, let's say I'm saying that a j is event that p, or let's say it is showing by q because it is probability, so q is not selected in uh in this in ag. So this one will be 1 minus probability of s1, s2, s3 and s4. Now it is not getting selected, that means we have chosen the books from the accept queue, so that means the other books can be selected, so it will be 19 by 20, it will be 19 by 20, it all will be 19 by 20. So it is 1 minus 19 by 20 to the power 4. So this will be the chance that it has been selected at least once. Okay, so next we will move to uh, okay. Next we will move to this question that in an SRS with replacement, that is SRSWR, of uh, three students from a class of 25, what is the probability that a specific student, say student A, is exactly selected twice? It is exactly selected twice. So that one will be uh, with replacement. So uh, the first time uh, it has selected, okay, so the chance of this getting selected. So let's say this particular one will be selected twice. So it is selected firstly one time. So for one, it is 1 out of 25, right? And then this particular one is selected twice. So this one will be this, and the third one will be some other, right? And then multiply by 3 because it can be 1, 2, 3. So this is basically once A is selected, it is selected again. And the other one will be the third student. Okay. The next question is that how many different ordered samples? So where order matters. Of size 3 can be drawn out of 15 using sampling with replacement. So it is SRSWR. Now here also if we have the replacement matters or order matters, then it will be as multiplied by 3. Okay. So sampling with a replacement and order matters also. So it is different order samples. So firstly, uh, the first one will be chosen from 15 C1. Next one will be 15 C1. Other one will be 15 C1. So this one is basically 15 multiplied by 15 multiplied by 15. So it is 15 cube. Now here we can see what is 15 cube. So 50 to the power 3 is basically 3375. So 3375 would be the answer. Okay. Now it doesn't matter when you say that order matters, etc. You will started using this B. Okay. Okay. The next is that an urn contains 20 distinct balls. Four balls are drawn with replacement. What is the probability that all four drawn balls are different? So it is SRSWR. But what we are saying is that we want that if it really replaced by uh, is it really different? So uh, this one is basically 20 to the power 4 because we can choose The sample can be chosen in 20C1, 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 and 20C1. In the above one, what we have is that the four balls needs to be different. So let's say I have chosen first time out of 20C1. The next time I cannot choose that particular ball, right? I cannot choose that particular ball. So that one needs to be the different. So it will be 19C1, the next one will be 18C1, and the last one will be 17C1. So this one will be the probability that it is uh, different. So this will make sure that if let's say A is chosen, then I'm not gonna take that A. So 19. So sample size is reduced basically. So right now it is 19. For the next one, I'm not gonna choose let's say A and C. So I will choose from B to up to whatever it is. Okay. The next is that which R command correctly draws a simple random sample of 12 observation, this without replacement. Without replacement. So basically, I have now there is one more thing. In in sample.int I can give this. If I will let's say give if I will give sample 12 sorry 60 in sizes. So it is like 1 to up to this. So either we use sample or we use sample.int, that can work. Now if so, first is that a vector data vector of this length 60. So we need sample this size 12 and the replacement is equal to first. So that will work for SRSWOR. This will work for with replacement and this will give an error. Why? Because let's say I will give 12 here and 60 here. Then it will give me an error that the replace is false, that the sample size is larger than the population when replacement is false. So if replacement is false, I cannot work with that. And then this, it will give a sample of size 60, not 12. So these are some things which you need to remember, that when you are solving one question, not only just for go for the answer, think about all other options also, how they are working. Okay, the next is that which R command will produce a random permutation of uh, the numbers from 1 to 10. So, what we can do is that we can just take and then we can see what is working. So, right now, firstly, we will check our answer and then we will take our answer and then we will check whether it is correct or not. Okay, so it is produce a random permutation from 1 to 10. So this will do this. If I will take 1 to 10 replacement is equal to true, then this will not work. Why? Because with replacement it will be, let's say, uh, let 2 is repeated, then let's say not 2, let's say 7 is repeated twice, then uh, w- one number needs to be missing. Because if I'm saying that 10, the size is 10, and then it is like replaced, so this and this it is same. If it is replaced and this is true, then it is replaced, so one number is replaced. So if 7 is repeated twice, then the other number which needs to be coming in 1 to 10, so that number will not come. Okay, so for this one and this is correct. So let us take this. So if I will take sample 1 to 10, it is giving me, you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I will do this, okay, then this is also giving me every number. Now if I will change it with true, then you can see here 4 is repeated twice, 1 is repeated thrice. So we can see that here 8 is not present, 9 is not present, 5 is not present. In the similar case, if we will do here and we say, sorry, place is equal to true, then also we can see here 2 is repeated thrice. So we can see that 1 is not here. Sorry, 2 is repeated 4 times. So 1 is not here, and then 9, and then 6. A lot of numbers are missing. So this is not the possible case. Okay. So this is this and this will be correct. The next is that in the sampling with replacement, so SWR, if an element has probability P of getting selected in a single draw, then what is the probability that it is getting selected in at least once in independent draw? So this is very similar what we have done here, right? In this question. So this is basically 1 minus uh, 1 minus p to the power n. So if we will see in the format, then at least getting selected is basically 1 minus probability not getting selected in n draws. So not getting selected is basically, so if it is selected, then it is p. If not selected, it will be 1 minus p. And it has not selected in any of n rows, it will be 1 minus p to the power n. So this one will be the correct answer. The next question is that a sample of three numbers is drawn from 1 to up to 8 using SRSWOR. Which of the following sequences is impossible to contain? So basically, without replacement here, so this cannot work. So this will be the correct answer, because here 257 all different, 816 all different, 472 all different. This one is the only where 334 is coming. So this is not all different. Okay. The next question is that in a study, a researcher draws a sample of 10 observations with replacement from a population. If the probability of selecting any observation one draw, so this is again the similar question based on that. So this will be basically 1 minus p. So this is 0.05 to the power now 10. So this one is basically 1 minus, and this is 0.95 to the power 10. So this one will be the correct answer. The next is that when drawing a sample of four individuals sequentially without replacement of group of 20, a particular individual is not selected in the first draw. What is the probability they are selected in the second draw? So it has not been selected in the first draw and it is doing without replacement sequentially. So uh, here we have seen that if it is this, this is the probability. So it is basically small n minus 1 divided by capital N minus 1. So this one is that 4 minus 1 divided by 20 minus 1. So this will be 3 by 90. So this you can also see that conditional one. So it is A, that means it is selected in the second row given that it is not selected in the first row. So if it is not selected in the first row, that means out of 19, the 20 is selected. And in the above, it is probability of A intersection B. So A intersection B is that it is selected in the second row and not selected in the first row. So that one will be uh, like 3 out of 20. So here you can also do by 3 by 19. So in that format also you can think that. Okay. Okay. So the next one is that a sample of two cards is drawn with replacement from a standard deck of 52 cards. So what is the probability that both cards drawn are aces? Uh, Now, so basically, how many aces are there? So we have enough a deck of 52 cards. The number of aces are okay are 4. So if we have 4 aces out of uh, so probability of selecting an ace probability of selecting an ace would be 4 by 52, right? So this one will be 1 by 13. So probability of selecting one ace win is 1 by 13. So probability of getting like both the cards needs to be ace. So the second one will should also be out of this 1 by 13. And since it is happening with replacement, so it means if we I have the ace 1 2 3 4 and I have selected this ace, then I can again select this ace. So this will be 1 by 13 times 2 ace with replacement would be 1 by 13 times 1 by 13. So it is basically 1 by 30 square. The next is that which R command will correctly draw a sample of 8 elements from a vector V where V contains the integer 1 through 30. So with replacement. So with replacement that means replace needs to be true. Replace is false, that means it is without replacement. This is replace true. So A and C are correct. So we are not gonna choose one single option A or C. We will choose D. Okay. The next thing is that from a population of 30 individual, a sample is a sample of 6 is drawn by SRS without replacement. How many different samples are possible? So 30 to the power 6 is possible when we have this uh, when we have this uh, with replacement. So if we will do, okay, so now generate all the combination. So with replacement we need the combination. So if we will do combination 30 out of 6. Okay, so it is giving me some values. So here we will see that it will be out of 30 individual sample 6. So SRSWR. So this one, it happens when it is SRSWR. But 30P6, 30P6 and then this one will not be happening. So this one will work, which is 30C6. So 30C6 we can calculator or in R programming. Okay. The next question is that a survey requires selecting 8 individuals from a list of 100 responded using SRSWR. So what is the probability that a given respondent is not selected? So uh, I have a list, let's say up to 1 to up to 100, and the samples I'm taking individuals. So let's say I1, I2 up to IN, I8. Okay. small n is 8. So what is the probability that a given respondent is not selected? So it is not select, it will when it will not be selected, that means it is not selected in the first one, in the second one, or in eighth one. So that means out of uh, if it has been selected, it is, so probability of selecting a unit, that one is n by n. This one is selecting a unit, so not selecting a unit will be 1 minus 8 by 100. So this one will be 1 minus 0.08. So it will be 0.92. So this one will be the correct answer. Okay. uh, The last question we have here is that in an SRSWR, uh, a sample of 5 drawn out from a population of 50, what is the probability that the two specified individuals are included? So the probability, firstly, if there is no condition. So when there is no condition, uh, choosing 5 out of 50 can be done by this way, like 50 C5, right? So 50 C5 or C55, whatever way. Now the condition is that the probability that two specified include individuals are both included. That means I'm saying that we need to select these two. So probability that these two are selected is 1, because I'm saying that we need to select these two. So the probability, what is the probability that two specified are included? So probability that choosing 5 uh, out of 50 given uh, these two are selected. So that means we need to select those two. So from other 48, and why other 48? Because it is without replacement. So from other 48 we need to select the 3. So from other 48 we need to select the 3 and the divided by. So this one will be the answer of it. So it will be 48C3 divided by 50C5. Okay, so these are the questions we have done in this class, and uh, we have, so wrapping up. I'm just wrapping up the whole class. So in the starting, we have gone through the simple random sampling with or without replacement, and then we have seen what is the difference between sampling unit and the samples. After that, we have done some questions based on that, and then we have also seen that how we can do this application on R. And one more thing is that we can change the probability of getting selected a number. So if I want to say that choosing this particular number the probability is high, or choosing this particular number the probability is low, then it will affect this random sampling. So this is regarding the today's class. If anyone have any question, they can ask. Okay. Or if like you can go through the whole class, and I will upload this obviously. So you can go through the whole class, and you, if there is any question, then there is a discussion form also where you can post your question, and I will have a look into that in my free time. Okay. So if there is no question, then I will end this class. Thank you for joining, and thank you other if they are watching this. Okay. Okay. Okay, then I am ending the class for everyone.